Alright guys, welcome to Unit 4, Lesson 2. We're going to talk more about the limit definition of a derivative. Today we're going to just do it with some other types of functions. Last time we did it with linear functions, constant functions, and quadratic functions. Today we're going to just kind of do it with some other ones. And the reason why it's kind of important to learn how to do it with other functions because the way you simplify it is a little bit different for each one. So let's go ahead and begin here. Now, as you guys know, I introduced to you guys last time the limit definition of a derivative, and it looks like this. So I'm going to write it again. But I'm going to make a little change. And the reason for that is because a lot of times mathematicians make this little change. It's a small one, but I just want you guys to not feel uncomfortable with it. So here's what I shared with you. Now, mathematicians, I think the reason for this is because I think they feel like this is just kind of clunky. They don't like that delta x symbol. So a lot of times what mathematicians will do is they'll just use a different letter in its place. And the most common one I see them using, although it really doesn't matter what letter you use, but the most common one I see them use is the letter H. So today I'm going to be writing it like this. And I'm just doing this because I want you guys to kind of get used to the different ways that this thing can be written, okay? But there's our limit definition, and today I'm going to be trying, I might slip and accidentally do the delta x because I'm used to that too sometimes, but for the most part, I'm going to try to use the h because I want you guys to get used to that as well because a lot of times mathematicians will use that instead. But having said that, let's go ahead and we'll jump into our first example here. So example 1, I'm only going to write these directions once today because the directions are the same after that for every problem we do. So the directions are use the limit definition of a derivative to find f prime of x. Okay, that's going to be our directions for every problem today. Now for today, my function, we're going to start off by talking about a rational function. So suppose I gave you guys this, 2x plus 1, okay? And I wanted to find the derivative. Now, we have a shortcut for this one, too. You could do low d high minus high d low, draw a line and square below. That'll give you the derivative, but that's our shortcut, right? That's not the limit definition, so we want to use the limit definition of a derivative to find this, okay? So let's go ahead and get started. The first step in doing this is to find your f of x plus delta x, but like I said, today I'm going to do f of x plus h. And so basically that means you're just going to take your function and you're going to plug x plus h in for the x. Okay? And then, yes, as usual, we're just going to go ahead and simplify it. So let's distribute the 2 into the parentheses. And now we have this. Okay? So that's step 1. Step 2 is we want to set up our limit definition now. So the limit as h, not delta x, but we're going to use h today. The limit as h approaches 0 of f of x plus h minus f of x over h. All right, so f of x plus h is going to be what we just found. And f of x is this. Okay? So far, nothing really all that strange has happened other than the fact that I'm using h instead of delta x. But step 3 is where things will get a little bit different, and that's why I wanted to devote another day to more practice with just different types of functions. Because this is a limit of a difference quotient, but what kind of a difference quotient is this? Well, this is a complex fraction. How do you find the limit of a complex fraction? Well, we learned that back in Unit 3. What you do is you multiply everything by the denominators to simplify your complex fraction. All right, so let's start by multiplying everything by 2x plus 1. Let's start with the smaller one. So I'm going to put 2x plus 1 here. I'm going to put 2x plus 1 here. And I'm going to put 2x plus 1 here. So now these cancel out. Nothing cancels out here because now I think some of you guys might think, well, why can't we cancel these out? Well, there's a little rule in math. You can't do this, for instance. Like if you have A times B over A times C, you can cross the A's out. But if you have A plus B over A times C, you can't do that. So anytime something is joined to another term by addition, division won't cancel that out because division only cancels out multiplication. So in this case, since the 2x is being added to 1, you can't cancel it out with anything down here. You can only cancel out factors, not add-ins. So let's go ahead and write our answer though. So we have the limit as h approaches 0. The bottom now looks like this. The top now looks like this. And all I'm left over here is a 1. So that's 1, and we're done there. Okay? But I still have another little denominator I need to get rid of. So now I'm going to multiply everything by the other little denominator. I need to multiply everything by this now. So now I'm going to put parentheses 2x plus 2h plus 1 here. Extend the fraction as far as I can. And then we also need to multiply this by 2x plus 2h plus 1. And we also need to multiply this by 2x plus 2h plus 1. Okay, now these do cancel. Why? Because you have this times this, right? So those are factors. They cancel. And now I'm left with the limit as h approaches 0 of 2x plus 1 minus 1 times 2x plus 2h plus 1 all over h times 2x plus 1 times 2x plus 2h plus 1. All right. So that's the first thing you need to do is you need to multiply everything by the little denominators to simplify everything. All right. Next, we're going to need to distribute this -1 here. We're still on step 3. We're still on simplifying. The simplifying step for these ones that we're doing today will be a little bit trickier than the ones from last time, and that's why I devoted another day to practicing this stuff. All right, and now we're going to just cancel some things out that we can in the numerator. So for instance, 2x and -2x will cancel each other out. 1 and -1 will cancel each other out. So we can get rid of all that. All right. And now we have the limit as h approaches 0 of -2h over h times 2x plus 1 times this. All right, now, step 4 is to remove the discontinuity. So now we're on step 4. Matter of fact, it might be helpful to see if I just go back and label these steps just so that they match what we talked about yesterday. So here was step 1, right? Here was step 2. And then everything after that until where we just got was step 3. So step 3 is simplifying. So the main step that's different today is step 3, just so you guys know. Okay, so step 4 is to remove the discontinuity. In this case, the only thing that causes me a problem is this h right here. Like if I try to plug in 0, 0 times anything is going to be 0, so that makes the whole denominator become 0. But that's okay because I can actually remove that discontinuity because those are both factors that divide each other out. And so now we have the following. Okay, after step 4, after you remove the discontinuity, you're good to do your direct substitution and simplify it. So in this case, I'm going to plug 0 in here for my h. And if you plug 0 in there, that just makes that term go away, right? Oh, oops, my bad. Hold on a minute. As soon as you do your direct substitution, you guys, the limit's gone. So we don't have a limit anymore once you do direct substitution, because the direct substitution is taking the limit. So since this is just going to cancel out when I plug the 0 in, I'm just going to have that. And a better way to write your answer, although that's right, and you could leave it like that, but a better way to write it would be like this, because it's that. All right? And that's the same thing we would have gotten if we had done low d high minus high d low, draw a line and square below, but this is the way you do it using the limit definition of a derivative. So I'm going to let you guys try doing one like that at this time. Let me find a good example for you. All right. So, student practice. Here we go. So I'm going to give you f of x, and I want you guys to use the limit definition of a derivative to find the derivative of this expression here. All right? So go ahead and pause the video and go as far as you can to see if you guys can find the solution. All right, so here's your solution. You should have ended up with the thing in the square in the bottom corner there, -1 over x minus 1 squared. Let's see why that is. Here's your step 1, f of x plus h. Here's your step 2, setting up your difference quotient. I didn't put the equals f prime of x, but that's okay. I just left that off of every step, but it's okay. Next one, if you multiply everything by this and by this, you're going to end up with what we have here. So that's the step you're going to want to really double check carefully to make sure you got right. After that, you distribute this -1 into your parentheses, and you get what we have here. After that, you combine your like terms. The x's cancel and the 1's cancel, and you're just left with -h. And that -h reduces with the h on the bottom, leaving us with this. And then finally, if you plug in your 0 here, the h is gone, so you just have x minus 1 twice in the denominator, so that's x minus 1 squared. So there's our final answer for your student practice. All right, so that's one type of function I want you guys to be familiar with for today. Let's go ahead and move on to another example here. So we did an example to show how do you simplify expressions that have complex fractions. Well, this is going to be one where we talk about how to deal with radicals. All right. So step 1 is going to look pretty similar to what we've been doing. And there you go. That's it for that. Just replacing this x here with x plus h, and everything else stays the same. Step 2 is going to look pretty similar to what we've been doing, that is. All right. Yes, I'll put the f prime over there this time. Why not? Okay. All right. Actually, there's a good reason for me not to put it there. I need that space for something in a second. So actually, I'll take it off. All right. Now, this is where things get different. Now, we've done this before, though. We're trying to find a limit, and my limit has radicals in it. Well, what did we do about that before? The last time we had those back in Unit 3, what we did was we multiplied the top and the bottom by the conjugate, which means I'm going to multiply this whole thing by itself, but with the middle sign being opposite. Okay, so what that's going to look like is this then. Got to write a little bit tiny. I don't have much space here. Oh, it's plus now though, right? And whatever you do to the bottom, top, you're going to do to the other side as well. So okay. So that's called rationalizing. That's what we did last time. And this is actually the beginning of step 3, where we start simplifying the expression. All right. All right. Now, how do we do this? Well, what you're going to do is you're going to multiply this first term by this first term. So let's do that. Now, 2 times 2 is 4, right? But the square root of x plus h minus 3 times the square root of x plus h minus 3 just gives you x plus h minus 3 without the square root. Because anytime you multiply a square root by itself, it just cancels it out, right? All right. And then it's going to be minus, because we're multiplying a negative by a positive. So we're going to end up with a minus here. But let's actually do the multiplication now. So what's this times this? Well, once again, 2 times 2 is 4. And the square root times the square root gives you the stuff that's under the square root, but without the square root. All right? And on the bottom, we're not going to simplify that. We're just going to leave it just the way it is there. So 2 square root of x plus h minus 3 plus 2 square root of x minus 3. Okay? All right, so there's that. And we're still on step 3 because we're still in the process of simplifying. So the next part to simplifying after you multiply the top and the bottom by the conjugate is we're going to distribute here, and I'll also distribute here. I'm not going to do anything on the bottom though. So that's going to give me 4x plus 4h minus 12 minus 4x plus 12. Okay. We're still on step 3. So after rationalizing, we distribute. And after distributing, we combine like terms. So boom, 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 boom. And that's the end of step 3. Now we're ready for step 4. So let's see what we have left. On the top, all I have left is a 4h. And on the bottom, I have h and then everything else down there, which is quite a bit. So let me write all that out. Oops. All right. So in step 4, we remove the discontinuity, cancel out the h's. And that leaves me with a 4 on the top. And then on the bottom, I have 2 square root of x plus h minus 3 plus 2 square root of x minus 3. All right. And now we're ready for step 5. In step 5, we actually find the limit by doing direct substitution. So if I plug this in, the h just goes away, right? And that leaves me with this. Now this is a good answer, and it's a correct answer, but there's a better way to write our answer. Do you guys notice how both of these have the same square root? I have 2 x minus square root of x minus 3 is here, and I have 2 square root of x minus 3 is here. If I put those together, that leaves me with 4 square root of x minus 3's, and actually in this case I can reduce these again and end up with 1 over square root of x minus 3. Now, you guys can always combine these like this, but whether or not this is going to reduce, that may not happen on your problem. But on this one, it just so happened to work out that way. All right, so let's kind of review the steps here, in particular the stuff that's different. So the stuff that's the same, 1 and 2, steps 1 and 2 shouldn't be too surprising to us. Those are pretty straightforward. But step 3, we start by rationalizing, which means you're going to multiply by the conjugate. After that, you're going to distribute. And after that, you're going to combine the like terms, which is going to cancel some things out. So those are the 3 really new steps there that are all part of step 3, which is first rationalize, then distribute, and then combine. Okay. After that, you're going to remove the discontinuity like normal. That's not any different. But I guess this last step here is also a little bit different. You will be able to combine your square roots together, just so you know, because they're going to be identical, into one square root term by just adding those coefficients in the front. And whether or not you end up reducing, like I said, that may or may not happen. It just depends on, every problem is going to be a little different. All right, so let me throw one of these at you guys and see how you do with it. All right, so go ahead and pause the video here and see if you guys can use the limit definition of a derivative to find the final solution for this one. Okay, so here's the steps. Step 1, your f of x plus h would look like this. Step 2, your setup would look like this. Step 3a, we would multiply the top and the bottom by that, which results in this. Then 3b, we distribute the negative here in the middle into the second set of parentheses, and we end up with this. And then step 3c, we combine all the like terms together, and these things cancel out, leaving us just with 2h on the top. Next, in step 4, we remove the discontinuity of the h, leaving us with this. Then for step 5, we're going to plug 0 in for h, which causes that to go away, and you end up with this. And since those 2 radicals are the same, we can combine them together as 1 and 1, making 2 of those radicals. And then once again, you guys do get to reduce, and you have 1 over the square root of 2x plus 1. So that would be your final answer for that particular problem. All right, so that's kind of the basic idea I wanted to get across to you guys. I'm going to show you guys a couple more problems. I'm not going to really do student practices for these, just some other examples, just so maybe that'll be helpful for you on your homework. So let's talk about this first. What if I gave you guys this? What about x plus h cubed? Okay, now we could work it out the long way, right? The long way would be to say, okay, well, x plus h times x plus h times x plus h. And then what we could do is we could multiply these out using the box method or whatever you're comfortable with. And then after that, you can multiply this times your answer and have your final result. But I'm just going to tell you what you would get because you're going to use it anyway, and it's just going to save you some time because these problems kind of take long enough. And so if you were to actually multiply this thing all the way out, the final answer would be x cubed plus 3x squared h plus 3xh squared plus h cubed. That's going to come in handy for one of your homework problems. So for instance, I'll do one here really quick. Suppose I had this and I wanted to find its derivative. Now we already know the derivative of that is going to be 3x squared, right? Now I'm going to go through this problem. I'm going to go through it a little bit quicker than usual just because we've kind of spent all the time going through the finer details already, but I just wanted to focus on this particular issue here. What about when I want to find x plus h? Right, that's our first thing that we do. Well, I've already told you the answer to that. You're going to expand it out and it's going to be this. That way you guys don't have as much work to do, you just have the answer, right? So if I wanted to find the derivative using the limit definition, it would look like this. Now in this case, the x cubes are just going to cancel out, right? And so that's finished there. And also this h on the bottom is going to take 1h away from here, 1h away from there. Oh, so now it's 1. And then 1h away from here. So I just did 2 steps at once there. I simplified like step 3, and I also did step 4, which is I removed the discontinuity. And here's what I have as a result. Okay, and then I'm going to go ahead and do my direct substitution. And these two things are just going to go away when I plug in 0, and the answer ends up being 3x squared. All right, so that's dealing with cubes, so you might want to be aware of that. And sometimes, you know, I could make life a little bit more challenging as well. Like, for instance, I could give you something like this. Okay, now why is this one a little more challenging? Well, because I've included a square and a square root. So that's like putting 2 of these functions that we've already learned how to do together into one problem. Let me show you what that one would look like. Now in our last lesson, I gave you guys a shortcut for that. So let's go ahead and use it. The shortcut for that one is going to be x squared plus 2xh plus h squared. And then we have the x plus h also. So there's that. And then if I wanted to move on to my next step, which is finding the limit definition, or the derivative using the limit definition, I'm going to put this entire thing first because that's my g of x plus h. And then I'm going to put the original function here all over h. And then I would need to rationalize. So I'm going to multiply the top and the bottom by the conjugates. Don't really have a lot of room here, but we'll just pretend like all those are there. Okay. Anyway, so when we multiply these, basically this one times this one is going to result in just having everything that's underneath the square root now outside of the square root. Same thing here. But we got to be careful. You want to keep them in parentheses because in a minute we're going to have to distribute a negative. And on the bottom we're going to have the square roots that are remaining because of the multiplication we just did. So we're kind of past the whole issue here at this point of what's new about this problem. But what was new about this problem is the fact that we had a square inside of a square root, and so we're really putting 2 strategies together. Strategy 1 is to expand this out, and strategy 2 is simplifying problems with square roots. So yes, I mean, they could be mixed together, and you could end up with some slightly more complicated ones. And so you'll see one like that in your homework. It's going to be a square combined with a fraction problem, though. So you'll see it when you get there. But anyway, at this point, if I distribute this negative, this x is going to become negative, and so is this x. And that's going to cancel out there, and it's also going to cancel out there. And then I'm going to be left with this. Okay. Now, At this point, we're ready to remove the discontinuity. Every term on the top has an h. So I could divide this h on the bottom into each term on the top. So that takes one h away here. It takes one h away here. And it also changes that. Now h divided by h there is going to leave a 1, just so you guys know. That's an interesting little thing we haven't seen yet. All right, so now I have the limit as h approaches 0 of 2x plus h plus 1 all over this big long string of letters. Okay, at this point I'm ready to plug 0 in for x. Now if I do that, there, and there, this is going to go away, this is going to go away, and this is going to go away. And I'm just left with x squared plus x, just like this one over here, right? But in this case, we actually have an x on the top, and I'm sorry, an h on the top as well, so that's also going to go away. And so here's what I have as a result. 2x plus 1 over the square root of x squared plus x plus the square root of x plus x. And as you guys know, we can combine these together, right? And we end up with 2 square root of x squared plus x. And we're done. And no, you can't cross these off. Why not? Because that 2 is it's with the x, which is okay, but the problem is it's also being added to 1, so you can't cross that 2 off. But there you guys have it. So you could have some other situations like that. You'll see these 2 special types in your homework as well. So you'll have one problem with a cube, so you'll need to know how to expand a cube out. And you'll also have a problem where you're going to combine 2 different strategies in one. All right? But beyond that, we've kind of covered as much as we're going to cover with the basic limit definition of a derivative. We are going to talk more about limit definitions of derivatives next time, but we're going to talk about a different form of it called the alternative form. But until then, we will see you guys later.